Now, since we already understand how the if-else statements work, and we also understand how the switch case statement works, or the switch case construct works, let's go ahead and look at some loops. Now, why do you want to use loops? There might be sometimes when you want to repeat a particular portion of code. For example, you want to do something maybe a specific number of times. You want to keep repeating it until something happens. And Java provides the looping constructs that you can use to address that. We have three basic loops. You have the for loop, the while loop, and the do while loop. And in this video, we would be looking at the for loop and the different flavors of the for loop that exist. And later on, we'll look at the other loops, the do while and the while loop. So let's bring up our NetBeans and start with the for loop. I'm going to create a method down here, public void do loop, for example. Don't mind the name of the method. All right, I have that method there, and I'll declare an array. I know we've not talked about arrays yet, but at least you have an idea of what an array is from previous programming languages. So I'll call it numbers is equal to, for now, if you don't know what an array is, let's call it a set. And inside that array, I'll put in some numbers. Oh, no. Let me not use an array for now, since we have not talked about arrays. I'll keep the array when we'll use the array with an enhanced for loop. Let's say we want to write a program that counts from 1 to 10, or maybe 1 to 100. One good thing for us to use will be a for loop. And this is the for loop. That's JavaScript. I'm sorry about that. Int x is less than or equal to 10 x plus plus, and I put a body there, and I'm going to initialize x to 1. All right, and I'll say system.out.println x. All right, let's see how this works. If we run this, it should first of all print us the numbers 1 to 10, and then I'll explain exactly what it's doing. Okay, I'm not calling it, so here I would say Java tutorials JT is equal to new Java tutorials, and I'll say JT dot do loop. I call the method, and now I run it, and I expect to see it print out 1 to 10. I have the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on my console. All right, let's see what's happening. Like the if statement, the for loop also has the for keyword. It has a set of parentheses, and then it has something that goes into the parentheses, and we'll come to that shortly. And it has a body which is defined by the opening and a closing curly brace. And like I said earlier, if you have just one statement controlled by the for loop, same as with the if statement, if you have just one string controlled by it, then you don't worry about putting it in curly braces. It's going to run just fine like the other. We see the same thing again. All right, so I'm going to put back my curly braces there. I like it when I have my curly braces there. To me, it makes my code look very readable and easy for me to understand. All right, so what's happening? We have the for keyword, we have the parentheses, and we have the curly braces that define the body of the loop. And inside the parentheses, you actually have 3 different parts. You see, each part is separated by a semicolon. The first part is what is known as initialization. we declare a variable and then we initialize it. Remember, you cannot use variables in Java without initializing them. Even when you have instance variables, they always have default values that they are initialized to. So we are declaring a variable, and this variable is called x, and we are initializing it to 1, which means originally it has 1. So this is the initialization part of the for loop. Then you have the test condition, which is a condition that is tested. If this condition evaluates to true, then the code inside here will be executed. And then you have the reinitialization, which will reset the value of x. And we have seen this operator before, plus plus, which always increments the value by 1. So in this case, every time this part is executed, the value of x will be incremented by 1, and that's how we can actually count from 1 to 10 when we run the program. So I would come here and I would say, yeah, what am I doing? I'm initializing the variable. Like I said, it always starts from the initialization because it has to initialize the value x before it starts using it in the loop. Once the if statement starts, once the for loop starts executing, immediately it gets to this point, it runs the initialization. Once x is initialized, then it gets to the test condition part. And what's going to happen here is it's going to test this expression here. This expression, like what we saw in the if statement, must always evaluate to either true or false. If you put something here that does not evaluate to true or false, then you are going to have a problem. It must evaluate to true or false. So we say x is less than or equal to 10. In this case, x is 1. Is 1 less than or equal to 10? This evaluates to true, and immediately this condition evaluates to true. What happens next is the body of the loop is executed. So when the for loop starts, we come here. Int x is equal to 1. Is x less than or equal to 10? This evaluates to true. The answer here is yes. So we get a true here, and it executes the body of the loop. Notice it has not come here to this reinitialization part where we have x plus plus. It has not come there yet. Immediately after the test condition, it jumps to the body of the loop. It starts executing from here, the opening curly brace, and it goes down. When it hits the closing curly brace for the for statement for this loop, what happens? It now goes to reinitialization. So what happens is we say int x is equal to 1. Is x less than or equal to 10? That is true. It comes here, it brings out the value of x, which is 1, and then it hits the curly brace. Once the for loop is finished, it's a loop, so it has to go over it again until this condition fails. So once it hits this closing curly brace, it goes now to reinitialization. It never comes to initialization. Immediately it executes the loop for the first time, it now goes to reinitialization. No longer this part where you initialize the value for the first time, but now the last part inside the parenthesis, the reinitialization statement. And now we say x plus plus. So the value of x was originally initialized to 1, and it executed the loop one time. It came here, it said x plus plus. Now x is 2. When the value is reinitialized, after reinitialization, it goes back to the test condition. Now x is 2. Is 2 less than or equal to 10? That evaluates to true, and then it executes the body of the loop again until it hits the closing curly brace, and it goes again to reinitialization. X is 2, so it brings 2 and it comes back up here. It says x plus plus. X is now 3. It goes back to the test condition. Is 3 less than or equal to 10? The answer is yes. So it executes the body again, hits the closing curly brace of the for loop, and then it goes back to reinitialization. X is now 3 when we print it here. So when we come here, we say x plus plus. What happens? It increments the value of x again by 1. X becomes 4, and then it goes back to the test condition. Is 4 less than or equal to 10? That is true. It comes here, and it prints out, and it keeps on doing that, going to reinitialization, test condition, initialization, test condition, reinitialization, test condition, like that until this condition will fail. When it's now at 10, for example, when we have x here at 9 and then it hits the curly brace, it goes back, x is 10. What happens? Sorry, it goes back up here, x is 9, it says x plus plus, x becomes 10. It comes to the condition, is 10 less than or equal to 10? That is true. So it goes back inside here, it executes this statement and then hits the closing curly brace and then comes again to reinitialization. Now x plus plus, x was 10, so now x becomes 11, and then it tests the condition again. Is 11 less than or equal to 10? No. At this point this fails and it no longer executes the body of the loop, but it jumps directly and starts sprinting down there. And that's exactly how the for loop works. Now there are some tricks. You probably want to rewind that and see exactly what's happening there before continuing further if you have a problem. Now there are certain things, there are certain portions of these parentheses, this for loop, there are certain portions here that could be left out. For example, if we leave out reinitialization, it will not pose a problem. But what's going to happen is our program is going to run forever. I don't know what's going to happen to my computer right now, but the value of x never changes. It's the value of x. If we take this out, what happens? The value, it goes down here. X is less than or equal to 10. X is 1. It prints 1. It hits the curly brace. It comes back to reinitialization. Remember, even though it is empty, I must always put the semicolon. I've taken out the semicolon and you see I have an error. So even though I don't put anything there, I must always have the semicolon to differentiate the three, to distinguish the three different parts. So when it comes here, it hits this part, it goes to reinitialization and there is nothing there. So the value of x will not change, x will still remain 1, and then it will test the condition again. And what happens? X is less than or equal to 10. X is still 1, so it goes back there, it prints, it goes back to initialization. X is still 1. It keeps on doing that and doing that and doing that over and over and over and over. And that's what is referred to as an infinite loop, which means it's going to keep on looping forever and ever since there's nothing. There's no doubt you could come inside here and maybe you do x plus plus to make sure that it does not loop forever. At least you have something in the loop that is changing the value. But let's put it back where it's supposed to be. Well, let me take it out for now. Remember, you must use the semicolons to distinguish the three different parts, even if you don't have anything there. The initialization part is also actually optional. I could decide to put it here. I could say int x is equal to, well, I could declare the variable out there and I could initialize it here. X is equal to 1, and the difference here is I simply declare the variable out and I'm initializing it. But I could completely take this out without any problem and maybe initialize the variable outside here instead. You see, all the other, I have the three parts, but the initialization and reinitialization are empty, yet the loop is going to run. This is still going to cause us an infinite loop because there is no reinitialization. I could go ahead and now put x plus plus on this side so that I have reinitialization. In this case, my program is going to run just fine because the value x has already been initialized outside here and there's no need for me to initialize it again, so I leave that part empty. So immediately when this starts running, it's going to hit this part, it sees that it's empty, then it's going to go to the test condition. X is less than equal 10 and we have it there. X has already been initialized to 1, so it's going to loop through every time it finishes this. If this condition satisfies, if the test condition here is true, it's going to hit this. If the test condition fails, then it's going to go out directly. But if it hits this and it's true, if the test condition here evaluates to true, it's going to execute the body of the loop, hit the closing curly brace, go back to reinitialization. Since we have something here, the value of x is going to change. And you could use anything there. You could count in reverse order by using minus minus. For example, you could do x minus minus. Anything you could do, x plus or x is equal to x plus 1, for example. Or let's say we want to print out all the even numbers from between 0 and 100, from 0 to 100. So what I could do is I could start by 2. 2 is an even number, and here I could say x plus is equal to x plus 2 plus 2, and as long as this is less than or equal to 100. So every time I go through reinitialization, instead of just adding 1, now I'm adding 2 every time. So if I run this, you see I have all the even numbers between 0 and 100. So what happens here is the variable x is initialized, then I start the for loop. It comes to this point, there is nothing inside here, so it jumps to the test condition. Is x less than or equal to 100? Yes, x is 2. So it executes these statements inside here. All the statements that you write inside here is going to execute them, and then once it hits the closing curly brace, it's going to go to the test condition, sorry, reinitialization, and then x is reinitialized to 2. You could still change this to that plus equals. We saw, sorry, plus equals 2. We saw this the other day as well. In the previous video, we saw this shortcut, the compound assignment operator, like the add and assign operator that we have here, and it's going to keep on doing this, reinitializing, testing, executing, reinitializing, testing until the condition fails. And you could use any expression that you want there to increment your variable. And if we run that again, we still have all even numbers between 2 and 100, between 0 and 100. All right, I think that's pretty clear enough. It's pretty straightforward, and I'm sure we got it right. If you don't get it, okay, there's one thing that I did not mention. There's no way the test condition is not, let me take this all out. Look at, we have it there. You see all the other parts are optional, but then you don't have any test condition. And if you run that, you see we have an infinite loop. It keeps on looping, and it's going to loop like that forever, ever. I had to force stop it like that. Same thing, even if I put this, sorry, even if I put this, and you see there's no increment, it's still going to loop forever. It's looping forever until it runs out of memory. That's why it keeps on printing 2, 2, 2, 2, 2, 2, 2. So you probably want to have that there. And now if we run this, fine. But if we take this out, if we take the test condition out now and we run it again, looping forever. Yeah, it's incrementing, but there is no test, so it's going to keep on looping till it gets out of memory. All right, so you see that you could leave out all the 3 parts, but don't forget, even if you leave out the 3 parts, you must always have the semicolons there to distinguish them, and your code is going to work just fine. Have that in mind. So I'm just going to put my code back to where it was. X plus equals 2. Well, I think we're done with that, and if we run this, it's going to be fine. You could still count from, you could count in reverse order by using minus, whatever, use your logic the way you want it. The next thing I want us to see is the enhanced for loop. As of Java version 5, Java actually brought in what is referred to as the enhanced for loop. This loop actually helps you loop easily and faster through collections, and I'm going to show you how that works. But before that, let's say we have this array. Let's say we have an array here, int, I declare an array numbers, and I put in some numbers there. Sorry, that's not what I wanted to do. And I put in some numbers there, like maybe 5, 6, 7, 10, 20, 15, whatever. I have some numbers there. I could use a simple for loop. I could do something like for int I is equal to 0, I is less than numbers dot length, and I plus plus. Well, this is simply an expression. Number length always holds the number of items in an array. We're going to talk about that when we talk about arrays. We have the initialization as normal, we have the reinitialization, and then we have the test condition here, right here. So it simply tests the value of I at every time to see if it's less than the number of items in the array, and we'll see later that array indexes always start from 1. That's why we are doing it to be less than the number of items in the array. But I just want to show you how tedious it is to loop through an array with the normal for loop, and then we see how the enhanced for loop makes it easier for us. So I could now say system.out.println, and I could say numbers, and I pass in the current index, which is I, and this should print out all the elements in the array. So when I call do loop, it should print out all the elements in this array on my console. I have all the elements in the array we had from 5, 6, 7, 10, 15, 20, 15. Same thing we have here. But let's do the same thing with the enhanced for loop. Okay, I'll print up something here. System.out.println using a normal for loop, and then I'm going to take out the ln so that it actually prints on the same line. When you put println, it prints the items one, it prints something on the string, and then it prints a new line character, after that, so that the next print will start on the next line. When I do print, it's going to print it all on the same line. I'm just doing that so that it's all visible on the console and we don't have to scroll. So I say system.out.println line, and I say using the enhanced for loop. And down here, this is the structure of the enhanced for loop. You have the for, you have an initialization int x, you declare a variable. Actually, you just declare a variable int x, you put a semicolon, and then I'll pass in numbers, and that is it. Or I could still leave out the curly braces and I just do something like system.out.println. Remember, I said when you have just one statement, then you don't need the curly braces, but I usually put it to make my code more readable. So I'll just say x and this. Now this statement here, or let me put the curly brace so that we actually see it clearly. Curly brace, not a pipe. All right, this statement here does exactly the same things as this one, but you see that this one is a little lengthier and more difficult to see. This one is quite evident. What happens here is you declare a variable that must be of the same type as the data that has to be stored in it. Like, we know that numbers is an array, and the array is an array of integers, so that's why we are declaring x to be integers. So once this happens, what we are saying here is for each value x inside numbers, print the value of x. Like, for each value inside numbers, take the first value. When you go through it for the first time, take the first value, put it inside the value x, the variable x, and then print it out. Go through it again, take the second value, put it inside X, print it out, go through it again, take the second value, continue doing that until you have finished the array. So you see that in this case, you don't need to bother about the length of the array. Like in this case, you need to get the length of the array. You need to work very well with the indexes to make sure that you don't get an array index out of bounds exception or whatever. You don't fall into something. But here with the enhanced for loop, you just use the array and or the collection. It's not necessarily an array, it could be any collection, and you declare the variable. It could be a collection of objects, a collection of everything possible. We're going to see a lot of that as we go deeper into our course. And like I said, when you say it has the same structure like the for loop, for, except that you only have this declaration part, and then you have the array that, or the collection that you have to loop through. In this case, our collection is an array. We're going through an array of integers. So what's happening here is we say for each value X in numbers, print out the value X. It's that simple. All right, I think that would do it for the for loop and the enhanced for loop. You probably want to go back through the video again, go over to it so that it sticks better, and practice, do some exercises. We're certainly going to come back to all of this later on when we look at some statements like continue, the break statement with loops and so forth. We're going to talk about all of that. But let's go on to the next video and we talk about the while loop and the do while loop.